So some people have observed that I was speaking boringly slow during my keynote, so I'm going to make an effort to speak a bit faster this time. Anyway, Rafael explained why SSO was a great idea during his conference on distributed systems, and the goal of this lightning talk is to show how you do it in practice. So the goal is to provide single sign-on to a neutral application. That is, you open the application with your browser and you're logged in. The context is that we're attempting authentication, just get the username, not permission selection or whatever, and we're only targeting private networks, that is a corporate environment, not the internet. The overarching as simple as I can make it in a lightning talk is your operating system requests a ticket granting ticket from Active Directory, which is the easiest way to recover us, and most corporate environments have it. And then stuff happens and your browser sends a ticket to Apache and magic happens and it works, basically. So on the server, you're going to have to create a key tab. This is some piece of cryptography that authenticates probably Apache to Active Directory and to your browser, etc. So it's very difficult to create one with the GUI, the graphical user interface of Active Directory, and the easiest way to do it is to use MSKTutil, which is an open source tool that does the job, and you create this key tab. And then you add a few lines of Apache configuration. You tell it that you're going to use Kerberos as authentication type. You point it to your key tab, and you declare the name of the service. So this is a kind of Kerberosism. You don't need to worry too much about it. The next line, curly method case 5 password off, disable the fallback to login password to avoid sending them in clear. If your site is only running over HTTPS or you have another kind of guarantee because that's a private network, you can remove this and then password may be sent in clear as a fallback if Kerberos doesn't work. And the next line tells Apache that you want to just the username and not username@company.com because you don't care about the suffix, you know what it is, it's your corporate domain. And you just require a valid user, for instance. Now, obviously, you're using Django for the application that's standing behind, and in that case, if Kerberos works, Apache is going to send a remote user header, and Django has everything you need built in to interpret this header, log that user in, and if it isn't found in the database, create a user on the fly. And to do this, well, just for the computation, basically you add a middleware and an authentication backend. And that's all you need to do on the server, so it's pretty simple. Now, on the client side, Windows systems that are running, that are tied to the Windows domain don't need to do anything, it just works, which is indistinguishable from magic. On OS X, it's a bit more complicated, but fortunately you have a nice little graphical user interface that's called Ticket Viewer that allows you to obtain this famous ticket granting ticket, and then stuff works. And on Linux or Unix systems, or OS X if you want to, you have the command line with a kinit command that basically requests a ticket. You have to install stuff if this works, but then you can see that you have a Kerberos ticket available. So that's on the OS. And finally, for the browser, if you're using Internet Explorer, once again, it just works. If you're using Firefox, because Internet Explorer knows about your domain and security policies, etc., so it's magic. If you're using Firefox, Firefox doesn't use system things, so you have to tell it that it is allowed to send the Kerberos tickets to the server, so you need to change a few settings. And if you're using Chrome or Safari, mostly it works, but sometimes you may have to access the service as a http://service or http service.company.com, because the browsers are a bit sensitive about this. So the longer version is available in this gist, and right after my talk I will tweet the link to the slides, which has the link to the gist, which has a complete manual with a few troubleshooting tips if you run into trouble. The only thing I didn't mention is that you need to have your DNS set up properly, and if things don't work, usually you have to fix the DNS setup and wait until it propagates, which is extremely annoying because you have to wait 1 hour before you can continue debugging. Thank you.
Now is Daniel.
Okay, so my big idea is to help establish a PyCon in an African nation. And by that I mean a sub-Saharan African nation, not North Africa, where things are different, and not South Africa, which of course has a PyCon already. Why? Because one of the keys to sustainable development in Africa will be the use of technology that they can invest in without sending their precious money back to the West, without buying Western products and services, or even receiving gifts from the West that in a few years' time will become obsolete and will need to be replaced at great expense, or perhaps they just have to wait for the next gift to come along. So that's not satisfactory. Sustainability requires that they can invest in their own engineers and developers, in their own universities, build up skills and expertise in their local economies that in fact can be exported rather than them having to bring this thing in from the outside. So that's why I think their infrastructures of health and government and so on will need technology, and the only sustainable way forward is for them to use open source products. Who's going to do this and where's it going to be? Well, I work at Cardiff University in Wales in the UK, and I have colleagues involved in projects in Africa through the university, so there is a lot of expertise there and connections with particular nations, in particular with Namibia and Zambia. And the other thing that this really depends on is a local community that's able to sustain something of this kind. So it can't come from the outside. We can help from the outside and be involved, but it has to be something that is itself sustainable, that the community can manage and build on and develop in other places around Africa. So it has to be somewhere where the community is ready for it. And there are a couple of places, Dakar, Lusaka, look like the best options. Well, I'm in no rush with this, because absolutely the worst thing to do would be to go into this with just good intentions, because making a mess of a project like this could screw things up for the next 10 years for everyone else. So it's not something that can be gone into without people who have a vast amount of experience of this kind of thing already. So we're working slowly towards that. And we would like to find more people to be aware of it, to be supportive, to become involved if they can, to make the connections in the West or beyond Africa rather, and in Africa and between the different communities. So we've got, there's some documentation on Read the Docs. It's all in Python's Dash in Africa. Read the Docs, there's an email list on Google Groups. If you want to make notes to or add things to the proposal, you can do it on GitHub. It will happen. I don't know if it will happen in a year or 2 years or 5 years, but it's something that's worth doing. And the last thing that's, why a PyCon and not something else? Because it's what's important is open source. The important part is not Python, however much we might like that. The important thing about Python is that we have the Python and Django communities, and you can only do things working with people whom you know and trust. And if any community is able to work together to pull off something as ambitious as this, I think it will probably be the international Python community. So perhaps you might join us. Thank you.
I now have maybe you share about loads. I don't know how you pronounce it.
Yes, loads. Okay, So I will talk about loads. It's one of the tools we are building at Mozilla Cloud Services. And basically, loads, so this is in Latin, but it means if you can make it, I can break it. And the aim of this application is to be able to answer this kind of thing. It's is my architecture for my software service is ready to handle all the loads I will have. Does it break under pressure? What's happened if it breaks? How far can I push my infrastructure? So there is different steps. You can start a load on your computer directly, and you will be able to throw like 65 sockets at a time to make requests to your website, for example, or you can have a local cluster or remote cluster. So it's really easy. You can also use SSH, and you can say, please run this test on my cluster. It's just a unit test, but we will also have some endpoints for Node or Go. But basically, you can use a session object that come from request or web test as well. And you will say, please do this scenario. So this is the architecture of loads. You have a broker and you have agents. You can start many agents on many computers, but you can also send them on different ones, and they will all talk with the broker and run the test. And from your computer, you start Loads Runner, and you can get the results from Loads Web. It's a dashboard. The dashboard looks like this. You can see all the tests, how many times they took, when they finished, and so on. The result is just an average time for each euro and the number of success or failure based on the assertion you made on your test. And you can also add some other metrics, and you can see them after. In the future, we want to change a little bit things, because for now everything is going to the broker and it could be a bottleneck. So now every agent will directly talk to the database, and after the dashboard will get the data. And we are, yes, as I said, we are building other load runner interface for Go and Node. And that's it. So please break your application with loads, but not other people ones.
So it's me again. Our friends Danny and Audrey from Two Scoops are not here. But they've sent this smashing print and a signed copy of the 1.6 version of Two Scoops. So what we've decided to do with these is a kind of raffle. So what's going to happen is this. Now, and at dinner, this hat is going to pass around the audience. And if you wish, put a little donation in it. €1, 5 or 500, we don't mind, whatever it is. It will be used to send an attendee to the next DjangoCon Europe, wherever that will be. Someone who would otherwise not have been able to come, and we hope someone from a place in the world where it would be very difficult for them to otherwise afford to come. No, not like Australia. Somewhere more deserving. Much more deserving, yes, yeah. So this will go around now and at dinner. Then you'll be invited to put your name into a text file on that computer. Again, you can do that now or at dinner. And probably we can find a program who can choose a random name rather than split. A random name of a file. Yeah. And we will choose a winner of the magnificent print and the signed book. Okay, so the rules are, you don't take money out of the hat, we won't be pleased about that. And you do not delete anyone else's name from the file when you edit. Okay? So I'll just let this pass round. You don't have to do it now, you can do it later, and you can come and sign that. We trust you because you are members of our community to only put your name in the file if you have donated. But there you go. It doesn't have to be euros, it can be dinars or whatever, dirhams or whatever it is that you have at your disposal. So thank you. Russell, it's you. Thank you.
Okay, thank you very much. Can I get the clock started so I know what I'm doing? There we go. Okay, so I am here today to talk about cricket. What is cricket? It's not just a sporting event the British can't play. It is a tool that I have written. But before I start talking about cricket, I want to back up a little bit and sort of talk a little bit about why I wrote cricket. Who here knows about or has heard about the Unix philosophy, or the idea behind the Unix philosophy? For those who haven't, the Unix philosophy is the idea that every tool should do one thing and one thing only, and do that one thing really well. And the power of Unix as a platform is that you take these atomic elements and you plug them together and you end up with very, very complex and sophisticated and highly tuned tools. But you can only do that because every single item, every single item in the chain is atomic and does one thing exactly. The problem that I have with the Unix philosophy is that there is a corollary that's come along with that, which is that every tool, therefore, must use the command line. The only acceptable user interface is the command line, and the only acceptable output mechanism is writing the console. What that means is that you end up with user interfaces like this. This is running Django's test suite on one of my projects that I've got, and this is your user interface to that testing process. Now, tell me, there's an F in the middle of there. Which test failed? There's an X a few along. Which one was the expected failure? They've got some output that's occurred in the middle here as a result of some date time problems. Which test caused those problems?
Bash VDB.
You can do a bunch of these things with those tools, but you don't get that information until the thing has finished running. Cricket is a tool that is designed to break that problem. It is a very young tool. It's only version 0.2, but it is stable. I've been using it in production. I'm using it on a day-to-day basis to run my test suites for almost 12 months. It does one thing and one thing only. It runs test suites. It can run both Django 1.5, so old-style test discovery, and 1.6, new-style test discovery, as well as Unit Test 2 style test suite. So if you've just got a vanilla Python project, you can run Cricket on it as well. How do you use it? Pip install Cricket and then Cricket Django, or Cricket Unit Test. It's a unit test, just a normal Python package. And what do you get if you run that? You get a user interface, an actual user interface, a graphical user interface. It actually uses TK-Enter. Notable features. Down the left, you get a tree of all of your tests that are going to run, organised according to the packages in which they are, that you can browse, expand and contract and do things like that. You have buttons to run the entire test suite, or just run that one, that one, that one, that one, and that one, or that one, and everything in that package. Along the bottom, you've got details that tell you which test is currently running. A progress bar that tells you how far you are through your test suite. A count of how many tests have passed and how many have failed. And an estimate of how long it's going to take for the rest of the test suite to run. If you select something in the tree, you can get the test run summary on the right. So you get the duration, the test doc string, any console or error output that's occurred, and a great big F if the test has failed. And you can get that while the test suite is running. So if you start seeing a bunch of errors occurring, you can go and check the exact errors that you're getting for that test suite. And there's actually a second tab you can move over to just see the tests that have got problems. But like I say, most importantly, you're getting all of this while the test suite is running. And if you get new tests, essentially you just press run all again and it will go and rediscover the test suite every time it goes. Makes it very, very easy to see patterns of failure. It's very, very easy to just rerun failed tests. It's very, very easy to rerun a single module or run every second test or something like that. So the idea here is that we've now got something that's compliant with the Unix philosophy. It does exactly one thing. It runs a test suite. It can be plugged into other things. There's backends and whatnot, so you can communicate back and forth. There is, for example, plug into another tool that I've written called Duvet to automatically generate coverage information while you're running a test suite. Which leads me to the fact that this is really just part one of a much bigger plan. I've got a sort of an umbrella project that I've been working on called Beware, the IDEs of Python. Essentially, this is a collection. My intention is to build a collection of tools which all follow this Unix philosophy, but are as simple to use as pip install this tool and it just works. So please try out Cricket, or if you're interested in the larger project, go to pyb.org and you can see the other tools that are in the suite, some of which are very, very nice, some of which are much bigger. Or pybware on Twitter if you want to catch up with any sort of notifications or what I put them out. I've got all sorts of grand plans, I'd love to discuss them if anybody wants to talk to me about them over the sprints. But other than that, that's Cricket. Yes, we've got an Australian cricket team, boo to the English. Thank you very much.
So we now have Diederik van den Bol.
Hello, I'm the author of Django Parlay, and it allows you to translate Django model content in a very easy way. And this is something that exists in the Django community for quite a while, but when you start making a CMS multilingual, you start using the existing packages. It turns out that Django model translation is like a lot of fields, but which language am I actually going to use for my project? It depends. So how can I make my migrations work? It's quite difficult, quite hard. So I looked at Django Vat, and it turns out to be really wonderful in the API. But then it overrides all kinds of things, and it makes it really hard to use, combine it with other projects. And like what projects? I mean, like, yeah, we're doing crazy stuff here. I have MQTT, you have polymorphic, and I want to combine that. And I want to combine it with translations. And that should all be possible in my world, my experience. So instead we want something where you have a separate table for the translated fields. And just have a language code. So each row represents a different language. And when you start hacking that, and like really hacking it in a very simple way, and you start using descriptors like, hey, it could work. You just have a field which proxies the correct translation. Well, let's just make a model. Hey, that works. And all of a sudden, you start getting a package which has a multilingual support in a very easy and convenient way, without all kinds of hacks. And that's what we ended up with here. Something that you can still do everything manually, but there's also an API layer that helps you build this in a much easier way. This is the top level API, where you can just add the translated fields in your model, and then it will generate a separate model for you, where all the translations are being proxied to the appropriate table. And you can just use it like a regular model. You can just read the fields, write the fields. And yeah, we have some pretty cool stuff in there as well, like query the translated fields, or prefetch existing, use the prefetch related mechanism of Django, get translated URLs, so you can tell Google which versions of a page exist. And because there is some caching involved, it's still quite performant. So there's no worry about all the separate queries going to a separate table. And to give you an idea of how this looks like, in the admin you get separate tabs for all the different translations. And in the website you have like the content, you can just switch it for 2 different languages in this way. And yeah, it does work with caching. I mean, like, this didn't have any impact on the performance of the website, fortunately. And because it's so simple in API and models, we actually implemented this in Oscar as well, using the same tab mechanism, and it was quite easy to implement, actually. So when clients actually want stuff like all different sorts of languages for websites, you can just do this and pip install Django Parlay, and you're set.
Benoît Brion on, I can't remember, DEPENDENCIES.
Okay. Hi. I'm about to talk about PyCutter, and PyCutter, it's about file generators. So you know file generation, start project and start up, you know how it works. You may know also a recent project which name is CookieCoder. It's a command line to generate files. It can read templates from GitHub. There are many other use cases for file generators in many languages. And there is an example where you can see a problem with file generation. As an example, for a human, the documentation is quite long before you actually start to generate things. So it's always the same pattern. You generate files using templates and you provide the data, whatever the engine. So the question, can we do it with a service? The answer is yes. It already exists in some way. As an example, there is a page in which you check some boxes and you generate files. Twitter Bootstrap is a kind of file generation tool. It's you know it, yes. And use cases are already numerous, multiple. So a challenge could be to render templates against data, wherever the template means on GitHub, on your computer, on Bitbucket, on storage, anyway. And whatever the engine, because we don't want to install things before we can generate files, we just want to provide the data to the template and get the files. With Remy, we talked about loads before. We started to implement it in DieCoder and published it as a service on DieCoder.io. It's open source, so you can come and help us. The idea is you have a template. There is a template for a Python project. So there are files in the folders. It's on GitHub. You set up HTML user interface. Everybody here knows how to do it, so it's quite simple. And you just post the data to DieCoder API, and it generates the files. It gets the files from GitHub, puts the data in it, and you get the files. As you can see, the benefit to have shared templates is that you can share best practices. Here we have docs on previous configuration and a nice setup. Currently, at the moment, DieCoder works, so you can already use it. The main point is that you can focus on templates and user interface, and your users can focus on the data they provide, and you forget about the generation implementation. We are improving DieCoder. As an example, we are planning to add the Django template engine. Currently it's engine, but maybe later we can plug Ruby or other languages because it's the same pattern. You provide the data, and it's a REST API. And also, I think if you try DieCoder.io right now, you will see it's quite slow. But if you have ideas about improving the performances, it's maybe mostly cloning from GitHub and things like that. You are welcome. And also we extracted the core of DieCoder and put it in a separate project called DieCoder, where we are trying to make the API and the features for everybody, and trying to converge with other projects like CookieCoder. Like DieCoder, we really developed a feature that makes it possible to render CookieCoder templates with DieCoder, and maybe later with a pasta script with a cheetah template engine and something like that.
So my name's Alex Moon, I work for Tangent Labs in London. I'm going to do a talk just on very elementary concurrency. It's kind of the new hot thing. We're doing a lot more sort of ripping the guts out of big fat Django apps and putting them into back-end services. I don't know how relevant this is going to be. How many people in the audience have actually done any concurrent programming in a concurrent language, with concurrent practices? Okay, a few, good. More importantly, how many people are using Django alongside some kind of queue with lots of different processes doing processing asynchronously? Right, a lot more. Okay. So, first of all, who is concurrency when she's at home? It's not parallel, it's not distributed, though it's not necessarily not parallel or not distributed. In fact, it's suited to both of these things, but at its base, it's a single process on a single box, and it's threaded, basically just context switching between threads, almost as though they were different processes, but with a certain shared memory. Very cool, it's very powerful, for the same sort of reasons that running lots of different processes side by side is very powerful. However, it comes with its own set of problems, which it's worth being aware of as developers who might start trying to write this kind of programs. In particular, there are 3 requirements for any current program. For some of you, this is going to be terribly elementary. For some of you, this is going to be completely head in the air. First of all, mutual exclusion, roughly speaking, data integrity between the threads. Freedom from deadlock, roughly speaking, the program shouldn't ever hang. And freedom from starvation, which roughly speaking is all inputs are processed the same way that they are when you iterate over them. The way to do this, the way to ensure these things, because you have things running side by side, you can't just step through it the way you can step through a serial program. So debugging is no longer an option. You have to prove these programs theoretically. The way you do this is by using a protocol. Protocol literally is just when more than one thread comes to the same piece of logic, the threads need to know which of them can run at any one time, wherever they're writing shared memory. This is part of why functional programming is really good for concurrency, but we're all used to Python. So it should be efficient when there's only one process coming in. It should know straight away that it can run. It should be when there's lots of processes trying to run, lots of threads trying to run, the minimal resource consumption. It shouldn't be using lots of processor or memory. Most importantly of all, it should be simple. It should be a one-liner if possible, a separate library which everyone can just import whatever. So let's dive right in. I'm going to write in Go because it's a very sexy language. If you haven't tried it yet, please, I can recommend it. C-like, curly braces, but with some added goodness, in particular this guy, which says start a new thread, and this guy, which is basically just a buffer between threads. You can pass it from thread to thread, and when you write to it, it'll just pass it back to whatever thread has it in scope. Very handy. We're going to take a long stream of numbers, and we're going to store means and standard deviations for these as they come in. The critical section, obviously, is we're going to update them based on the old means. So if the old mean is wrong, or if the old standard deviation is wrong, then we get the wrong answer down. Right. First attempt, just throw them all at the code. So the code looks roughly like this. It's ugly. I'm not a Go programmer. We basically generate a ton of words, we give them a random score, and we pass them back through a channel. Now, we are literally going to, for each of these scores as they come in, just flying at us forever, we're going to start a new thread, and we're going to do new method, which is just, it's very basic. This is how you work out a new mean based on an old mean, a new standard deviation based on an old standard deviation. And we're going to do these all side by side, and then we're going to write them to a big long list of these terms. So let's give it a go. Basically, this is all available on GitHub. The sources are on the slides. Go, run, first attempt. So the first thing that you notice, the synchronous, this is just a standard serial, whatever. I'm just out of timeline. Okay. I'm going to jump off, but you can see the rest of the talk online. I'm Alex Moon, thank you for listening.
Those on testing.
Thank you. I need to start with an admission. I'm Peter and I'm a testaholic. That means that I spend a lot of time writing tests and thinking about how to write better tests. And polytesting is the latest proof of concept project that came out from a lot of my frustrations that we experienced in our company. And I'm just going to run through it in 5 minutes, hopefully. So, who here is familiar with the test pyramid? Just show of hands. Some people. Essentially, it says that write a lot of low-level unit tests and then make sure your components are integrated, and then just write a few integration tests to make sure that they play nice together. Except some people can do that, and a lot of respect to them, but most of the time what happens is that we have a bunch of green tests, all the components are working, except when you deploy to production, it's completely broken because of unexpected interactions. The alternative is that you do a full stack testing, Selenium, Apache, everything else, except then it's impossibly slow, it's brittle, and it takes forever to run. And when something takes forever to run, it's not going to be run. So the idea is that let's give the same set of tests, and let's run them in different contexts. So the developers can run all the fast tests in memory against the business logic, and then later on the build server we can actually let it run all the Selenium tests, and then we have the best of both worlds, fast feedback and thorough feedback. Now this kind of polymorphic approach is not new to testing, because a lot of people run their same test against different databases. A lot of people run their Selenium tests against different browsers, when you take one set of tests and just run it in completely different configurations. Not to mention talks, but I'm not going there. So essentially what we want to do is create an abstraction and describe our test the way our users would do. In, like, let's say if you have a Kanban board style application, that if we have a board with some initial state, then I can move a task from one person and state to another person with another state, and then I just want to assert it. The important thing is that the test itself just describes the test and specifies the API. It doesn't contain the implementation. The same way that the Chrome and the Firefox drivers are different. Then we can go on and write the basic API for our business logic, where we have some kind of a board objects, whether it's a model or whatever, doesn't matter, and then we say move. Then, if that passes, we can write something with the Django test client, where we set up the URLs and then we make like some posts, and if the post doesn't give you the expected redirect, we raise an exception. And when you get to the UI part in Selenium, you can just go and do a drag and drop event the same way your user would do it. The benefit is that QA can write your Selenium test because they are so much better at it than I will ever be. But we are using the same set of specifications across all departments and all tests. Just going to run through the inspirations. So anybody familiar with BDD is going to recognize the kind of abstraction. Earlier, before we talked about, some of the presenters talked about the ubiquitous language and BDD and how it helps communication. If you're familiar with the hexagonal architecture, then it might be familiar, as well as the page object pattern, if anyone heard of that. The current status of the project is that I've got a 95% done project. I need some JavaScript problems needs fixing, and then I'm planning to write it up. And eventually, I hope there's going to be some library or framework coming out of it, and it can be found on GitHub. But for the time being, if you're interested in these kinds of things, come and talk to me while we are on the island, or just email to me at hello.joadasp.edu. And just to demonstrate that it actually works, let me just run it, and thank you for listening.
On Jungle Village.
Hi everyone, I'm here about another Django conference, which will be the first complex window, well, not really the first one, but let's say this is the first one this year. So, will be in Orvieto, which is a nice town near Rome, which is 1 hour from Rome by train, I guess. And will be in this nice palace, really. And it will be like in June, from 13 to 15 June. And we already have the tickets available, and they are really cheap. They start from 60 euros per person. So, and then yes, yeah, you can already buy from the website, which is this one, DjangoVillage.it, and you can follow us on Twitter. And if you have questions, please find me. I will be here. Thank you.
We now have Nathan Dutoit, who is going to tell us about building in 12-factor Django app.
Hi everyone. So to start, can I have a show of hands who know the 12-factor app? That's pretty good. For those that don't know, it's available at 12factor.net. And basically it's a set of methodologies, 12 of them, to build web apps, software as a service apps. And in software engineering, we don't get a lot of defaults and constraints that are applicable to everyone. And standards don't really exist. So this is something close to a standard. And basically it's a set of methodologies and good practices that will help you not fall into the same pitfalls that a lot of people have fallen into. So we don't have time to go over all the 12 factors of them. And in particular, I want to go over a few of the factors and how we can apply them in Django. So the first of them that we're going to consider is config. And basically, the gist of it is to store the config in an environment. And we've all heard that config is a bit of settings is a bit complicated in Django. So what can we do about it? So first of all, split your config files. And you might have already done that. There's multiple ways to do that. Just do a Google search, you'll find many ideas on how to do that. The key that I would like you to follow is don't split one for every single environment that you can possibly imagine. If you have production and staging and a bunch of test environments, don't create one setting file for each of them. Create one setting file for each class of environment. Maybe one for local development where debug is true, but then things for production, stick to one production file that you apply to staging and production, because staging and production should behave the same. And for the things that are different between your different environments, such as staging, production, variables are not defined inside of your code, because that would just defy the purpose. Those environment variables should live on the specific environment. So on your production server, you should have a set of environments variables defined. So it's a bit tricky to keep track of these environment variables. Like if you don't use source control, you're going to think, well, how do I keep track of them? How do I recreate a new server from scratch? There's a tool called Enter. It's built in Python. There's an equivalent also built in Unix, but the Python equivalent works really well for Python projects. And it basically allows you to define a single directory in which you define a bunch of files. Each file is going to be considered an environment variable. So if you have a file called foo and the content is bar, you're going to get an environment variable foo with the value bar. And the way you run it, you simply run enter with a path to the environment directory, and then your Django executable. And once you have that, those environment variables will be available inside of your app. And then in your settings, you can start using those environment variables. And that will take care of this problem of, instead of having a massive load of config files, you can have a couple of them and then still have multiple environments that you can support. The second one we're going to look at is dependencies. And basically what the factor says is that we should explicitly declare and isolate dependencies. So to do that, you use requirement files, obviously. You use virtual envs. Something you shouldn't do is use a single virtual env on your production servers and update it, because that will prevent you from being able to roll back. So you should have a virtual env. If it doesn't change, it's fine to reuse it. But if the virtual env is going to change, then you should create maybe a new one and reinstall your packages. There's different ways to go around the slowness of that, and if you want, we can talk about it later. The other thing you should do is package and version your internal apps. Consider them like external apps that you would install and have the same diligence about them. And to do that, you want to use your own PyPy server. There's different options out there, such as local shop and DevPI. And finally, one more thing that we're going to look at is the fifth factor, build, release, and run, where those should be separate steps. Strictly separate the build and the run stage. So to do that, what do we build? You might think there's not much to build, we're not compiling stuff. But you're still building static assets. You could build your virtual env in advance so that it doesn't have to be done during deploy. And that will allow you to do fast releases, where a release will just be to push some code and use a virtual env that's been already built. And it will allow you specifically to be able to roll back. If you use Symlinks, you will be able to do a quick rollback in production. And another thing you want to do is separate your code deploy from your config deploys. So the config you mentioned before, you want to be able to do that separately from doing a code deploy. So this is just a couple of things that you can do to follow the 12-factor app. You're welcome to ask me questions later on. It's very interesting to see how you can do that. Thank you.
We now have Thibaut Joannet, who is going to explain JavaScript like if we were 5.
Okay. Hi everyone. My name is Thibaut. I'm French, not as French as Bruno Bor, but still. And I'm going to talk about JavaScript for Python developers because someone has to. We French people, we like Python because we are romantic people. And when you want to seduce, a man, you can't just read Python because Python is like poetry, it's like Baudelaire. Look at that, it's very, very clear, very elegant, okay? Add a glass of wine and a bit of Mozart, and there you have it, perfect romantic ambience. And then there is a JavaScript equivalent, and you're not gonna seduce anyone with that. And if you do, honestly, good luck with that. So if you're like most Python developers, when you see JavaScript from time to time, you're like, ugh. Okay. The problem is like we are web developers and where JavaScript is pretty unavoidable today. So we're going to talk about a few differences, and we're going to try to bring some love for JavaScript. So the first key difference between Python and JavaScript is how do you create objects. Python is very French. You have to be very, very, very polite. When you want to create an object, you have to ask for permission first. So you define a class, and then you use that class to create an object. Okay. With JavaScript, not so much. You need an object, just create an object. Okay. So you don't have to mess with the classes, and so you just create objects. Okay. That was easy, but where is my class? You can ask, because classes are cool, we like classes. And the fact is, there are no classes in JavaScript. There is no such concept as a class in JavaScript. And what are we going to do? Because what is the class for? Classes are very useful for creating objects, for sharing code between objects, and for structuring your code and running it. So let's look how we can do that with JavaScript. There is a problem with this example. You may notice that I'm creating a user property, a user object, and that user has a toString property. What is a method? toString is a method, okay? And the problem is every single object that I create using this function has a copy of the method, has a copy of the toString. So every object has a toString property which contains the complete code. So that's bad. So how can we share some code between related objects? We we are going to use something that is completely magic. We are going to use prototypes. We are going to use something that is a prototype. When you every JavaScript object has a hidden magic link to another object property that is called prototype. Prototype is just an object like any other else. And there is a syntax in JavaScript that you can use to create objects that really looks like a class, but it's not a class. It's just a function that is used to create object that you call with a keyword, the new keyword that you can see behind. And look at that, it's very cute. JavaScript is so desperate for love that it's trying to disguise itself into a class-oriented language. And there are no classes, but good try. And what does a new keyword does is that it is going to link the object it creates with the prototype property of the function that creates the object. So it looks a bit complicated, but you can share some code by adding it to the prototype property of the constructor. Okay, and when JavaScript does not find a property in an object, it will gonna find it in the linked property. So by using this syntax, you can share code between objects without compiling it to every object. And if I still have 1 minute, okay, I could have told you about the models, but that will be for next time on the next slide. Thank you very much.
Embiez is going to tell us about live demos.
Thank you. So I was under the impression that there would be a mic here so I could type in both hands, but you know what, I'm just going to deal with it. Here's where my single hand typing is going to come in handy. You're going to watch how fast I can type with this. So anyone here not heard of BPython at all? Okay, you're in for a treat. Okay, BPython is a fancy REPL, which means it's just like Python.
Whoa, that's fast.
Yes. And then if you install BPython, it's just a matter of just doing pip install BPython, and it'll install BPython. And I'm going to show you the feature of BPython that makes it fancy and awesome. Let's clear the screen. Start BPython. It's just like how you would start Python, just type BPython and it starts up. Here's where the magic starts. As I start typing, it starts to automatically recommend suggestions for me. Let's import a module. As I start typing again, it starts recommending. I can tab and cycle through the different options. Let's pick time. Let's see what are the different functions that are available. So it looks like if you are a beginner, doing a dot on a module automatically brings up all the functions that are available for you. Let's pick one of those functions like time, and let's see what's the documentation has to say about that. That's a little bit messed up because of the resolution and stuff. Let's just close that and let's look at a different example. Let's do a little bit more complicated one called collections. And let me choose the counter. Now counter, again, I'm going to do a dot and look at all the methods that are available for me. Pick one that looks interesting. Let's do most common. Again, type it correctly. Sorry, typing with a single hand. So if you are opening a bracket right away, the documentation comes up. Now that is awesome. That kind of makes the deal for me in BPython. Okay, if I read this and I go like, oh, this looks interesting, I wonder how it is implemented. All you have to do is press F2, and it shows the source code. It pulls it directly from the standard library, and you can actually take a look at it. Let's quit out of that. And it's not just for your standard library methods. I'm going to create a method on the fly. So let's create one. I'm going to type really fast. Okay. Sorry about that.
Okay, let's return x, y, and let's get started. So as I start typing, even though it's a method that I created on the fly, it auto-completes. 4, 5, and now I do p.out. I don't have dot strings or nothing comes out. Oh, I forgot to put self. So if you are on Python, you would have to retype the whole class. But in BPython, I can just hit Control-R, which rewinds, which takes me back in time. And return self.x and self.y. So anyway, if I do p.out, I actually get the answer out. So that's BPython. Anyone else impressed by BPython? Woohoo! Did anyone actually believe that I typed the whole thing? No, I did not. So this was actually a recorded demo, and it allows me to replay the demo using simulated keystrokes. And you saw that it actually captured pop-ups that happen in the screen. You can go into Vim. I'm going to show you how it's done. So it's a software called Play It Against Sam. It's an open source Python module. You just do pip install Play It Against Sam, and you use it. So I have it installed, and Pious Record Demo 1. I'm going to record another demo live. I can type whatever I want, and it automatically records them and puts it into the dem1 that I just created, the dem1 file. 1, 2, echo, hello, sleep, done. So you may have noticed that I'm actually recording Pious Record inside of a Pious Record. So it's like, anyway, it's nested. The point I'm trying to make here is, let's finish that. I can actually open Vim. I can type whatever I want inside Vim. That is also getting captured. So it's as long as it's inside a terminal, it'll totally work. Okay, I am done. That's why there's gibberish there. So the way I replay that is, now I can type whatever I want. And as soon as I hit enter, this is exactly what we just recorded just a minute ago that I showed you guys. I think I'm out of time, so I will leave you with that. So the name of the program is called Play It Against Sam, and I just keep typing. I will say just one thing before I leave. There is a couple of options called auto waypoint and auto type, which I don't even have to have done the whole typing. It actually does it for me. There it is.
We now have Yann Mallet, who's going to tell us about hotbots and real time.
So I'm going to try to describe what BotMe, and can I have a show of hand of who know what BotMe is? A few hands in the audience. So it's an IRC logger that we mainly build for us at Lincoln Loop, and then a friend of us start to ask us if they can also, or if we can also log their channel, and then friend of this fine start to ask us if they can log the channel, and we right now have about 150 channels logged, and many of the Django channel all over the place are logged. And actually, while building this, we went through few iterations, and we find out that building real time is kind of hard. And the guy that was on stage before was trying to talk about threads, coroutine, and all this, and we went through that process of learning this lesson, and hopefully I will be able to show you all my slides. So I'm going to try to describe how all this is working, and I will start by the top where it's written where. This is a Django application which is actually having few models. The one that are interested is the network, which would be something like Freenode or Mozilla channel, because we're also logging Rust. channel, and there is few others that we have. And we have also something which is called chatbot, which is the nickname of the bot, which will be like someone joining on IRC, which is connecting to many channels. It's someone that loves IRC and he has a funny name and he's joining 150 channels. And then we have the channels themselves, where we are associated log and storing all this into a Postgres, and it's fantastic. We are super happy. It's great. And we also have the guy here, which is a Django application. It's eating everything coming from IRC. He's joining 150 channels and reading the line, and we are throwing everything into a Redis queue. The line are in that Redis queue and are built by plugins. The plugins at this point are Python applications that read from this Redis queue and do what they have to do. So we will have a plugin called Brain, which do what a brain can do. It remembers things, and we are throwing this into another Redis database. And we have one which is a bit special, because this one has access to the database. And when the line came in, you read the line, do things, and store it into Postgres. This is about half of the story. We are logging the channels, and this is captured forever. The next thing is, you want to display it to the user, because I was going to ask us to log their channels so they can read what happened when they were not online. So we have a fancy web application, which is Django, which is displaying this, and you see the channel. And very soon, this is great, and you can look at IRC on your mobile phone, and it's fantastic. But every time you want to get what's new in the discussion, you were in the need of reloading the page. We say, must have something better. So we started to play around, and it was a problem that we were already facing with another product that we are working on, which is called Ginger. And we decided to go this time with an event source endpoint. So event source is, think about it like a long polling HTTP connection. And so what we are doing is, as we are saving every line into the database, we have a signal that also sends them into a Redis channel. And we have a very small application which listens to this channel and listens to the users that are connected and dispatch the lines that the user is interested in and display them in the interface. So this is all good and nice, and now you're asking, how do you do the private channel and the connection? And I just listen to any random channels. And this is where it gets a bit interesting. I have 30 seconds to tell you this. So the user gets into the web interface, and the web interface, what it's doing when it actually get into this channel, we do the Django authentication. And once the user is validated, we put a token into, again, Redis, with the list of channels this guy can join. And at the same time, when this web page display gets passed and JavaScript gets evaluated, we read this, we go to the channel with the browser, ask the event source endpoint, which is in Go, and he reads the list of channels, he sees this guy is authorized, and access the channel, and actually get the information. Thank you very much, and this is about DjangoCon.